Hello, hello, hello. So, this is my usual mic check. If you're here watching live, please just leave a comment to let me know that, um, you can hear me, because it will be upsetting to do this whole video and you can't hear me. All right, so I can't find where the project is on my desktop. It's like I don't remember where I saved it, but that's okay. We can quickly go to GitHub here. We can quickly go to my GitHub account and then find the repo right here. Insurance premium prediction. Where did I say that? Should be on my desktop though. Yeah, I don't remember. I don't remember where I saved it, but that's okay. I can just clone it again. Let's go. Let's open PowerShell. Let's do dir. Okay. CD desktop, I believe. All right. Let's see. Um. Yeah, I don't know where I saved it exactly, but that's okay. I can just clone it. Clone it. See, this is one of the reasons why we put things online on GitHub, so that if you're like me, you forget where you like saved stuff, you can just clone the updated copy of it. All right. Let's see here. Let's do git clone this. All right. Let's see dir cd. Ls does the exact same thing as dir and PowerShell. So I'm using Windows PowerShell. Let's do cd insurance premium prediction. So from here we have the data, we have the model, the git ignore, license, pip file, and everything. So we have everything in here, which is great. Let me just go ahead and do pipm shell to initiate my pip environment. So just in case you're wondering, you always want to initiate your pip environment on the same folder level that has your license in your readme. It's just a good thing to do. It's a good habit to get into, so you don't have to create a pip shell inside a pip shell. All right, so I think my pip environment is initiated. I mean, one of the things I don't like about PowerShell is that even when it initiates a pip environment, it doesn't make it obvious when you are in a pip environment and when you are not in a pip environment. That's very annoying. Um, I guess I wanted to use. Actually, let me just do code. All right, so let's see what we have here. So we have the model. This is, and then we have our data set. This is not working as expected. Let's do this again. Yeah, this is supposed to be a Python file, but it's not recognizing it as a Python file. Let's close this, and from here let's just exit this. Let me use command prompt so I can know for a fact that I am in a pip environment. Let's go to, let's see, I think I'm just looking for command prompts. Yeah, so let's see here, cd desktop slash actually ls doesn't work in command prompt, so that's a little nifty thing. Ls doesn't work in command prompt. So now from here let's do pipenv shell, pipenv shell. Okay, so now we are in our virtual environment, and I like the way command prompt does it. It's very obvious when you're in virtual environment and when you're not. With PowerShell, like you don't have something like this that tells you which environment you are in. So it's not obvious when you're in a virtual environment or not. So cool. Now let's do code dot. Let's open stuff from here. And I don't know why this is not rendering. Let's see. Huh. That's strange. Okay. So why is VS Code not recognizing this as a Python notebook? Alright, something is wrong with Visual Studio Code, and that is not converting Python notebooks into Python notebooks. So something is wrong with VS Code, and that's not good. That is not good. So VS Code is not recognizing Python notebooks as Python notebooks. Control Shift P. Let me see. Python. Let me see. Can I do notebook from here? No. Something's wrong with VS Code. So yikes. Yeah, something is not right here. So I'm going to save this. I'm going to save everything, and later I'm going to figure out why VS Code is not recognizing this. Let me see if it's going to recognize a Python thing. Yeah, it's being recognized as Python here. Alright, let me do something like 1 plus 1. I'm just going to debug this real quick. Yeah, something is not right here. Let me see. Yeah, something is not right with VS Code. I don't know why it's not like functioning as usual. So yeah, this is recognized as a Python file for sure, but when I go to IPython notebook, it's not recognized as an IPython notebook. So I may need to update my VS Code. Let me see if I can use this to change it. Let's see. Well, it's not a Python file, and Jupyter Notebook is not on this list. So yeah, something's wrong with VS Code. Okay, that's okay. We have backup plans. Well, I have a backup plan. Let's go ahead and save everything, and let's close out of this, and let's just use Jupyter Lab. When all things fail, use Jupyter Lab. But particularly the reason why I liked using VS Code over Jupyter Lab is that, you know, VS Code does autocomplete, but Jupyter Lab doesn't. So yeah, something is not right with VS Code. I'm going to figure that out later. Let's just use Jupyter Lab for now. I have some other stuff open. Desktop. This is all right. So cool. All right. So let me go ahead and run all of this. And let me see real quick here. Let me see. All right. So let me see here. And I'm just going to run all of this again to get it up to speed. And if you were not here last week or last 2 weeks when we last worked on this project, I'll give you a quick overview. So last week we basically just imported the data. So the total objective for this project is to do exploratory data analysis, wrangle the data sets, build a regression model to predict insurance price, do some model interpretation, create Amazon. I meant amazing. Create amazing visualizations using Plotly, and Tableau, and then we'll deploy our projects using Flask and our Plotly using Heroku. So that was the objective. That's the overall objective. So what we've done so far is we are still in the exploratory data analysis phase. So I know everybody wants to rush and get to the data building the model part, but building the model is the easiest part, and it's the easiest part of this whole project. You have to do a lot of work before you get to the point where you build the model. So yeah, and then so went ahead and imported the data set, and this is the data set here, what it looks like, and this is a profile report, and based on this profile report we were able to create a list of the things we could do to explore the data and also clean up the data. And this is just, I'm looking at the different data types. And last week I did sns.pairplot, and I passed in insurance, which is what we named this variable, and it created like 70 megabytes of data and everything froze. So do not do sns.pairplot on a large data set like this one, because everything is literally going to freeze. I'm not kidding. So let's say what do you want to accomplish today? Like, what do I want to start with? Um, this is whole lot of things to do, right? This is a whole lot of stuff to do. So I think I'm just gonna pick a few things and work on it today, and then next week we'll pick a few more stuff and work on it, and just keep working on it. Keep like hacking away at this project one day at a time, right? All right. So let's see here. Let's see. Um, so this is something else we want. We want to find the meaning of column names. Yeah. So we had like two objectives of things we could do. We could have one of the targets we could do is predicting the insurance premium. Another target we could do is predicting customer lifetime value. So that's one of the two things we could accomplish with this project overall. But we'll see. We'll see how it goes. Why is this not creating a new line? There we go. Alright, so our profile report says no date column, which is wrong. So we need to convert our date column to date. Okay, that's something else we could tackle today. So let's go back to the profile reports real quick here. Oh, this is new. This is a little bit different than what we had last week. Reproduction. Overview. Right, so let's see. I believe we had a date column. Effective to date. So this effective to date is categorized as a categorical variable, but actually it is a date. So we need to convert this to date. Alright. And then let's see, what other work do we need to do? So month since policy inception, this is month. Okay. Month since last claim. Okay. Monthly premium auto. I'm looking for date. that are categorized as categorical variables. This is new actually. I haven't seen this before. I think this is kind of like a new, or maybe Pandas profile report has been updated, you know. And oh, by the way, I didn't show you this before, but right now we are working in the virtual environment. So if you click on this, you can see which virtual environment we are using. Um, so Python Interactive is what we are using, and this one right here, Python 3.7.5 64-bit insurance premium PPENV. This is the virtual environment we are using right now for this project. And when you come here, you could change the environment you're using. So if we go back here to the command prompt, right? I did PPENV, I did PPENV here to start a virtual environment, and this is the virtual environment that I created for this particular project right here, right now. And this virtual environment is what's being used even when I am in Anaconda. So from here, you could switch between different virtual environments. I didn't point that out before, but that might be important for you to know. Oh, hey, am I working in the right environment? Just look up here in Jupyter Lab and you'll find out which environment you're in. All right, so, but anyway, this is kind of this is different. I haven't seen anything like this before, so I'm not quite sure. Interactions. I'm not quite sure what this is saying. And then I'm familiar with this. This is a correlation. I explained this last week. So you could go back to last 2 weeks video and revisit all of this. But so far it seems like effective to date is the only date column that is being recognized as a string column, as an object, as a categorical variable. So we are going to convert that into dates. All right. So if we put an X here, it adds a check mark to our stop. All right, so let me just make a note here. So convert effective to date to dates. Just to be clear which column we are converting. All right. So convert effective to date to from categorical to date. That's what we are doing here, and as you can see, effective to date has been recognized as an object as opposed to a date. So let's find the syntax for it. As you keep watching my videos, what you'll realize really quickly is that I sort of struggle with syntax a little bit, memorizing syntax. So often I Google syntax. Okay, I just focus on understanding the concept. I meant to use what, but I don't focus so much on memorizing every single syntax in data science because I know I can easily find it with a simple Google search. All right, that's my advice. Don't feel bad if you Google syntax like me. It's normal. All right, let's say objects to date pandas. pandas dot to data frame, to date time. All right, so pandas dot to date time. Let's say argument errors rate. All right, let's look at the documentation here. Parameters: integer flow string date time list tuple 1 series data frame dictionary. Like, okay, and this is the argument here is the object to convert to date time. Okay, so let's see here. Errors. All right. Format the string. Actually, I don't think I do not care about the date time format, so I'm just going to leave that. And for date time format, actually I'm going to turn this, so the default for this is false, but I want it to be true. It returns a date time. Alright, I want to see it used an example. So whenever I read documentation for something, even if I've done it many times before, I just still like to look at the example of how this is done. So data frame is equal to, alright, okay, so that's converting the whole thing to data frame. Okay, I want to see, well, these are not very useful. Alright, let's just convert effective to date to date. I'm not sure we are even going to need that column. I want to see what does effective and insurance mean. Hey, if you're an insurance professional, I know, so an effective date refers to the exact date and time your insurance policy will officially become active. Okay, so I could name this better. I could say insurance. So basically this is me just creating a new column for this insurance, and I want to call this activation date. Activation date. That's what, I want this to be equal to pandas dot to date time, and in parentheses you pass in the column that you want. So effective to date, and for, so this is one of the things I don't like about Jupyter. There's no autocomplete. Let me see the syntax. And for datetime format, this is what I'm looking for. Equal to true. Alright, so basically we are creating a new column called activation date, which is equal to pandas dot to date time the activation date will just basically be this right here, but instead of it being recognized as an object, it will be recognized as a date. That's if this works correctly. So let's go ahead and execute this code, and we get an error. So let's see here. key error. All right, so did I spell it wrong? No, I didn't spell it wrong. So let's see. Mm, 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 mm. Hmm. Okay, so let's go back here and see. Oh, okay, so there are spaces in between this. So when it's listed right here, it puts underscore right here, but the actual character separator is a space. So let's execute this now and see. All right, it works. And just to verify it works, we could do ensure. We could just copy this again here. So now we have a new column called activation date. That is a date time format, and this activation date should be the exact same information found in effective to date. So let's see, effective to date. And just to verify this information real quick, wait, I like how this is not showing everything. How do I make it ooh, okay, so if I right click and do enable scrolling for output, I can scroll through it as opposed to showing all the information. That's nice. Now it doesn't work on markdowns. Cool. All right, so that's something cool to know. So so it won't take up too much space. That's really dope. Let's just do insurance dot head, and let's see real quick. So dot head automatically only shows the first 5 rows, if you're wondering. And let's see. So effective to date, and then we have activation date. As you can see, um, the information here is the exact same information here, but now this is recognized as a date, and this is recognized as an object. So I'm guessing at this point we can go ahead and drop this column since we no longer need it. And I renamed it from effective to date to activation date, just because in my head activation date makes more sense than effective to date. And Google tells me that effective to date is means the day your insurance kicks in. If that's wrong, just let me know in the comments, because I don't know a whole lot about insurance. So yeah, I'm hoping Google is right that effective to date. Wait, effective to date, does that mean like when your insurance ends? Huh. I don't know. Because effective to date could be interpreted as effective until this date. That is the day your insurance ends. So I have to spend a little bit more time on this, trying to figure out exactly what this means. And depending on what I found out effective to date means, I can rename this column to be more descriptive of the data in it. So let's see, to date could mean the day insurance starts, or could be interpreted as the day insurance ends, as an effective until this date. So you might see me like taking some time to kind of comment on stuff. That's really important, mainly because as time goes by, like even next week when I come back on this project, I'm going to forget stuff, and I'm going to forget why I named stuff, why I named them, why I did what I did. So it's always good to add comments like this on your code as you're writing it, so you can keep track of what is happening. And so when you come back to this project next week, you know what's going on. Alright, so let's see, what else do we want to do? We want to drop a couple of columns, I believe. So we've done this. Drop customer column because it doesn't matter. Yes. So the customer data has been anonymized. If we go down here, it tells you the customer number, and I'm guessing this doesn't matter because this information has been anonymized. So I want to drop the customer column. I also want to drop the effective to date column because I have a column that has the exact same information as this one. So I no longer need this effective to date column. So let's do that. Let's see. I'm going to override this. And let me see here. Data frame dot drop. Okay. And then the labels. I have to specify the axis because the default axis here is 0, and which means row. But I have to specify the axis equal to 1, which is for columns. So instead of specifying the labels, which is the list of columns, and then also specifying axis equal to 1 like I was about to do, I could simply do columns equal to labels. That's cool. Okay, yeah, because I was going to specify the columns here and then specify the that I was going to specify the column names, specify the columns, but instead of doing that, I could just do columns equal to this. I do not want the operation in place, so the default is false, so that's okay with me. Alright, let's go back here and execute it. So this is here I'm going to do insurance dot drop, and what I was going to do before was labels equal to customer, and then effective to date, the two columns that I want to drop. and then axis equal to 1. So originally this is how I was going to do it, but I'm not going to do this. Instead of doing this, I could just do the columns equal to this. So this is what I was talking about. I'm not going to write extra line of code that's not necessary. So I'm just going to do columns equal to this. And now let's do insurance dot head. So here, as we can see, the customer column has been dropped, and the effective to date column has been dropped also. Cool. Let's go ahead and save this, and let's commit our changes so far. So let's do git add everything, and let's say git status. So we added new files here, which I'm going to delete later. So let me go ahead and remove test.ipymb. How do you remove stuff in command prompt? Let's find out. I don't want to force Windows to delete if I just want to freaking delete a file. Oh my gosh, what's the syntax? That's it. Delete. Delete test.ipymb. I could have sworn it's right here. You're right, it's not here. Let's say cd data dir, and from here cd, I need to go back to model. That's your stuff is. So test.ipython notebook is what I need to delete. I need to delete test. I mean, I could have done this from Jupyter Lab too, but alright, so IPython notebook is gone, and it should be gone from here too. So let me see here. Let's make this font 20 looks good to me. I'm too big. 24. 20 sounds. 20 looks good. It's not going to take effect immediately, but let's do dir, and let's go ahead and change this. That looks a whole lot better. I wanted to change, let me see. Yeah, I wanted to delete test.py. Okay, so now let's do get status. Let's go ahead and do get add. Alright, so I've deleted all the other files, and let's go ahead and do get commit message. Let's say I changed. What did I change? Change to date time, and deleted and dropped columns. You know, Git, you suck. Just know that. Git commit. It's throwing an error because I had space between this right here and this. It's throwing an error because of this space. git push origin master. Alright, let's do get status again. I'll make sure everything's online. Alright, we're up to date here. Let's get back to work. Yeah, and this has been updated. The file is gone from here, which is great. Let me go ahead and refresh this. Alright. Our changes has been updated online. And I know this seems like slow and boring work, but whenever you hear data science, this is actually what data science is. Like, most times people think data science is like fancy models, AI, like, the kind of AI stuff that you see in movies. That's what comes to mind whenever people think of data science. But data science is actually doing work like this, where you're like exploring the data and exploring the data and exploring the data, creating visualizations and making some changes, and just stuff like that. This is data science. The model part, the random forest and stuff, that's kind of like the last part of this whole data science process. But this is fun. I enjoy this. Like, I don't feel like I'm working right now. I'm chill and I'm doing my own thing. But let's see what else is on our list of things we want to do to this data set before we proceed. Drop customer column, because it doesn't matter, we've done that. I want to encode coverage column from categorical to integer. Okay. We want to use customer lifetime value. That's one of the target values we have. So here we say we could use we could predict lifetime value, and we could predict insurance premium. So let's encode coverage column from categorical to integer, and let's establish our main baselines. I'm guessing that's something else we could do next. But before I get to the part where I establish mean baseline, I think before I get to talking about my target, establishing my mean baseline and other stuff, I just want to finish sort of like cleaning up the data a little bit. And at the end, I think I'm going to take all of this and put it in a function. So I'm the type of person that I do not put stuff in a function from the get-go. I like to do things line by line. I like to do things just one line of code at a time, so I can really understand what's going on, what's happening, and all that stuff. And then once I know everything works, then I take the code that I've written that I know works and put that in a function. So in the future, it will be easier to replicate my code. But yeah. So encode coverage column, and then change customer lifetime value to 2 significant figures. Interesting. So I'm going to encode coverage column, which is categorical to integer. Let's start with that. Coverage. Okay, so right here, okay, so I want to see something. I want to see if could I do dot describe on a series. Let me see. I know you could do it on an entire data frame, but could you do it on a single column? You could. All right. So 3 unique values. So I don't know if this will work though. That didn't do anything. Okay, so basically, coverage is basic, extended, and premium. Um, in this situation, the value that we give to basic, extended, and premium actually matters. Okay, so we could do basic. We could give basic the value of 1. We could do extend. We could give extended the value of 2, and then we could give premium the value of 3. So when you're doing categorical encoding here, you have to be kind of careful, like the impact, how like your encoding will impact your model. At the end, of like towards the end of this project, like when I actually build my models, right? The number I assign to each one of these is actually going to impact my model. So that's something you have to think about. So in this case, I'm going to use 1 to represent basic, I'm going to use 2 to represent extended, and I'm going to use 3 to represent premium. And there are a couple of ways to encode this categorical thing. In this situation, one hot encoding is not going to work. I could do ordinal encoding, but I'm very, very, very specific. I really want basic to have the value of 1, extended the value of 2, and premium the value of 3. And since this is only 3 values, I think what I'm going to do hard coding. Now, if I had like many different values, like like states, then I probably want to do manual coding. But in this case, I'll do hard encoding. Let me see. Let me Google real quick different encoding techniques. So categorical. Let's look at this. So we have different encoding techniques here, right? So we have one hot encoding. One hot encoding is not going to be good for this situation. Ordinal encoding. So in one other feature, an optional mapping dictionary can be passed in. In this case, we use the knowledge that there is some true order to the classes themselves. Otherwise, the classes are assumed to have no true order and integers are selected at random. So in this case, I think I might actually use ordinal encoding, and I'm going to pass in a dictionary to it. If I'm going to do ordinal encoding, I need to install category encoders in my virtual environment. And I could do the encoding process when I build my model. But I want to go ahead and encode it upfront because just makes life a little bit easier and clarifies things. And I'm going to build visualizations to further explore the data set even before I get to the part where I do the model. So yeah, I want to go ahead and encode my categorical variables up front. Yeah, I do want to go ahead and encode my categorical variables up front, and that will help with visualizing the data. Alright, so let's see here. I'm going to use ordinal encoding. Let me see. Hmm. Should I go ahead and do my data splitting, like kind of split my data set up front? Actually, I should. Oh my gosh, I messed up a little bit. Did I do test? No, I didn't do that. That sucks. I just remember that. It's always best practice to split your data up front before you do anything to it. So I even before I did this change, and even before I did this change, before I did this, I should have split my data set. So now that I just remember this, let me just go ahead and do my train test split, if that makes sense. Let me just go ahead and split my data set into train test validation sets before I proceed. I should have done that right from the beginning. It escaped my memory. Yeah. I should have done trend test splits all the way like up here. So yeah, even before I did anything else, I should have done the trend test split. Well, that happened, okay? I can go ahead and fix it, but the changes I've made so far are not so major. So I'll just go ahead and do it here. So let's do let's actually add it right there. So real quick, let me go here to my paper file to see what I have. So in my paper I have pandas profiling, I have number, and I have Seaborn. I don't have scikit-learn. I need scikit-learn in this virtual environment. So I'm working from the insurance premium virtual environment. So for me to do train test split, I need scikit-learn, and I also need category encoder. So let me go ahead and install this. Let me see. Um, mm, okay, so PRP install. Okay, that's what I'm looking for. Let's go to here. Let's see. ppenv install category encoders, and Is it called scikit learn or sklearn? I think it's sklearn. Let me see. Oh, it uses scikit learn, but when you import it, you use import sklearn. I always forget which one is which. Okay. All right. So let's go back to our virtual environment here and let's do ppenv install scikit learn. So I want to people have installed scikit learn and category encoders. All right, we'll let that install. And we'll just play the waiting game. If you have any questions, just let me know, either in the chat section of this or in the comment section below. And we'll just wait for stuff to log. Moments of silence for the pip file while it logs. I've thought about playing music in the background, but I don't want to run into copyright issues. I need to find some copyright free music to play in the background. Personally, I don't use music when I'm coding. I just like the silence of everything. But I know some people like music, and in situations like this, when we're waiting for our file to lock, having some kind of music to play would be nice, right? Just so you guys, just so it's not like super silent the whole time. Why is it taking so long to lock? I know from past experience when my pip files don't lock, nothing in the virtual environment works correctly. So I've always wondered why. Maybe this is the time to Google it. And if you're watching this video, like let's say 5 years from now, and you have questions about any of this, you can let me know in the comment section of this video. Wow, and it is still locking. Let's find something else to do. So when this is finished, we are going to import scikit-learn to do train test split, and we are going to import category encoders to encode this. And we can go ahead and build the dictionary that we're going to use. So let's call it coverage dictionary is equal to we'll say if it is basic, we want it to be 0. And if it's premium, we want it to be 1. Now let's do 2 here, because in this case, right, we want the natural order of stuff matters. Actually, this is premium here. We want it to be 3. So in this case, natural order of stuff matters. That is why I am giving basic 1, extended 2, and premium 3 as the encoding, because obviously basic is the lowest one, and then you have your extended, which is a little bit above basic, and then you have your premium, which is the highest level of insurance you can get, right? So the natural order of stuff matters here. There are times when natural order of things doesn't matter, and in that case, like when I encode the state, the natural order of the state doesn't really matter. So I'm just going to use ordinal encoding without specifying the natural order of stuff. But in this case, the natural order of stuff matters. And even when I do education, right, the natural order of stuff matters, because a master's degree is above a bachelor's, a PhD is above a master's. So the natural order of the encoding in education is going to matter. So okay, so somebody just suggested something in the comment section, so let's try that. Let's do this. Dot value, oh great, dot value count. I didn't even think about that. Yeah, so Steven, yes, yeah, so Steven is right. So Steven in the comment section suggested that I do value count, just to verify that everything is either basic, extended, or premium, and just make sure, verify that there are no typos. So, and he's right. So we have like 5,000 basic, 5,000, 2,000 extended, almost 3,000, and then about 800 premiums. So yeah, everything is basic, extended, and premium. Yeah, so ordinal is when order matters. Well, not always though, because if you look at category encoders definition, right, here this says uses a single column of integers to represent the classes. An optional mapping dictionary can be passed in. In this case, we can use the knowledge that there are some true order to the classes themselves. Otherwise, the classes are assumed to have no true order, and integers selected at random. So ordinal encoding is like when we provide a dictionary using the dictionary mapping parameter, then we are implying that natural order matters. But if we do not provide any dictionary, then it assumes that order doesn't matter, and then to just select random integers for the classes. So it is both of them. So let's go back here. An error occurred while installing Matplotlib equal to this. So I'm guessing this error is coming from installing dependencies from paper.log. I've never seen any. I've seen a lot of paper.log error messages, but I haven't seen anything like this one before. Installing initially failed components, 3 out of 3. So it worked. Well, I guess everything worked. Let's go back here and look at our pip file real quick. And here we have scikit-learn category encoders. Okay, we have stuff that we need. All right, so yeah, Steven says I'm correct on that one. So yeah, so so this is our coverage dictionary. But before I get to this, let me go ahead and execute this so I don't forget. But I wanted to do trend test split on stuff before I continue, because I made one change to the data frame before splitting my data frames. Actually, no, I'm not specifying a specific version. So if we go back here, so here I just did pipem install scikit-learn category encoders. So I didn't specify the version, and that's why my if you look at my pip file here, it just says this star is wide card. That means all versions. So I didn't specify the version to use for the packages. I guess I could if I had a reason to, but in this case I really don't have a specific reason. But Python was automatically added here, Python 3.7. Alright. Yeah, just keep the questions coming. If you have any more questions, just let me know in the chat. Alright, so let's go ahead and import sklearn from scikit-learn.preprocessing. Import trend test split. I think that's the syntax for it. From sklearn.preprocessing, import trend. I think somebody should just build a module that does autocomplete in Jupyter Lab. It will save everybody so much time. Let me see. Oh, it's sklearn.model selection. It's good that I checked. And let me see. This is simple. Let's do. I'm just going to do my train, and my test is equal to train test split. And I want to do. So I have about 9,000 rows. I think I'm going to do. Maybe 70% for. I think I'll probably do 70% for the train. So trains, I need to specify the. Okay, so train size is equal to 0. Let's just do 0.9 because I'm going to split this twice. Hold on, let me see. Can you do a 3-way split using train test split? Let me see. Let me go 3-way split. Yeah, I mean, usually I just do it twice. I usually just do train test split twice. That's what I usually do, but I want to see if there's a way to do it in one time. So np dot split data frame dot sample fraction equal to 1. So I didn't know you could use numpy to do splitting. Huh. That's new. Okay. Oh wow. So let's see. If indexes or sections an integer, the array will be divided into n equal arrays. Access. Okay. Um if indices or sections is given as an integer, but a split does not result in equal division. You know what? I'll Google this later, but I'll just use what I know for now. So I want to do, let's see, 10% to be 900. I don't want that. I think I want maybe 15%. So let me do 0.85 here for train size, and then test size is equal to 0.15. So 0.15 will be a little bit over 1,000. Okay, sounds good to me. And then I want to random state equal to 42. And again, I want to insurance. This time I want to split the train data into train and validation data. And at this time I want, so here, let me go ahead and run the first one real quick and kind of see what my data looks like. Invalid syntax. Did you already see this? Okay, let's do train dot shape about 7,000 rows. Let's do test dot shape about 1,300. So 10% of this is going to be about 700, and 15% of it is going to be very close to the test size. All right. Validation data set. All right. All right. Now let's do val.shape and see what it looks like. Okay, so the validation data is about 1,100, which is a little bit less than this, which is fine. They don't have to be the exact same size. And now let's run this cell again and see. So now we have about 6500. So we could change this to, let's say I think it's good. Maybe. I kind of want about, like, well, the more data I have for training, the better. The better my model is going to be. So I'm just going to leave this as it is right here. So I'm going to go ahead and delete these code cells just because they make my stuff not look good. And I'm going to take this code cell. Usually I do my refactoring when I'm done like building everything, but this is just an easy refactor to do right here to just clean up the. Alright. So okay, so I've done my train test split here, and everything I'm going to do right now, I am just going to do it on the training and the test data set. Like all the data cleaning I'm going to do, just training and test data set only. I'm just going to pretend as if the validation data set doesn't exist. And when I'm done with all my entire project, I'm probably going to when I'm going to do my data cleaning on my okay, I think I might like just do my everything on my data cleaning on my training data set, and then once I'm done with cleaning up my data based on this list, then I'm going to kind of create a function for wrangling my data, so I can just pass in my training, test, and validation data set and clean it the way I want. But right now, I don't know exactly what I'm going to do, so I'm just going to do things line by line until I figure out what I need to do. Then I'll create a function for data wrangling. Alright, so now let's import category encoder. Use ordinal encoding. And let's say import category encoders CE. Yeah, so that's the right syntax. And then CE encoder equal to CE dot ordinal encoding. Ordinal encoder. Cool. Alright, and then alright, so verbose equal to 0. Column list. A list of columns to encode. If none, all string columns will be encoded. Okay, so I need to specify the column to use. Columns equal to none. Alright, let's start implementing this. So let's see, let me just be specific here. It's helpful to be specific with your, it's very helpful to be specific with naming your variables. Let me go ahead and add this as actually let me do get add, get status, yeah, get commit message, and I want my message to be did train test split. Get push origin master. All right, so get is huh unable to access get init get status. Okay, get push. All right, get status. So now my branch is up to date. So here my branch was ahead of origin master by one commit. All right, so now I'm good. Now let's do ce.ordinal encoder. Okay, column is equal to coverage. All right. Calls. Okay, the keyword is calls. A list of columns to encode. If none, all string volumes should be. So it wants a list. Does it provide an example here? It does not provide an example. How nice. Alright, so this is calls. Let's put that in a list. And then the other keyword we want to use is mapping. Alright, so calls mapping equal to, okay. So in this case, I'm going to do mapping equal to coverage dictionary. Okay, let's shift enter this. And now let's execute our category encoders on our test data set, and subsequently on the training data set. So let's do I think I want to do fit transform, and then transform. All right, let's do coverage encoder.fit transform coverage encoder until fit transform the training data set, and then I want to transform the dot transform the test data set. Alright, we run into an error, so let's see. String object has no attribute get. What? Does it want this in a list? Let's say column is equal to switch dot get column. X column is equal to x column dot map switch mapping. Let's try this and see. Invalid syntax. Cool. String object has no attribute to get. Switch dot get column. Self dot mapping. X mapping columns handle unknown handle mapping out equal to mapping. For switch a mapping column equal to switch dot get, and the string object has no attribute get. Let me see, what am I missing? Mapping list of dictionary. Okay, so this is how they want. Okay, column mapping, a mapping of class to label to use for the encoding. Option: the dictionary contains the keys column and mapping. Okay, the value of column should be the future name. The value of mapping should be a dictionary of original label to encoded label. Example mapping. So this is how they want them. This is the mapping structure right here. So I'm just going to copy this and okay, so this is the struct. This is all right. So this needs to be in a list, and let's do mapping, right? Okay. And now let's do, wait, what? Let's do call is the name of the column, and the name of the column in this case is coverage. And all of this needs to be in a dictionary. So this is the correct structure for using mapping with ordinal encoding. So you have the column, which is the coverage, column, coverage, right? And then we have mapping, and this and two of this. And okay, so I think this is right. Let's go ahead and comment this out, and let's call this correct mapping structure for ordinal encoding. Alright, we still have problems. Let's see. Ordinal encoder has no attribute trans. Of course, it has no attribute transform. Duh. Woohoo! It worked. Okay. Ah, finally. Alright, so now let's do train dot head. Why is it giving it -1? That didn't work as it's supposed to. Let's do the describe and value count. Oh, yikes. That did not work at all. Let me see. What could have gone wrong? Let's say dot value count. It just used -1. Okay, that's strange. I've never seen anything like that before. Usually when I use ordinal encoding, I just do it automatic and I just let ordinal encoding assign whatever value it wants to this. But in this case, it's not. Alright, so let's go back to documentation real quick and see if we can find anything. Does the mapping has to start from 0 though? Is that necessary? Let me see here. What's going on? I'm going to, just for clarification, because if I run this again, it's just going to give me negative. It's not going to work because coverage is no longer categorical variable. But let me see here. Maybe I do have to begin with 0. Let me go ahead and let's say I just, okay, yeah, that's fine. Let me see. Ordinal encoding outputs -1. I'm trying to see here what's going on. Maybe I can find something. This website. Okay. So we are done here. Okay. So in this case, this is going to be train encoded. All right. So okay. All right. So does this match with the data we had before, right? So let's see. Originally we had this. Let's just verify that this matches the data we had before. All right. So the original training data set had 4,000 basic, 4,000 ones, 1,900 extended, 1,900 twos, and 577 premium. So 577 premium. So okay, so everything works as expected. So that's good. That's really good. So now we have verified that our encoding process works, and I'm just gonna make sure it also worked on our test data set. And of course, at the end of this project, I'm going to refactor everything and take all of this data cleaning process and put it in a function. But before you put anything in a function, make sure it works. Let's change this to test here. I think Control Shift M. And I have no clue what I just did. Control Shift M again. Okay. Well, that happened. I wanted to see Shift what is like the shortcut for new cell? Is it Control M? Control M? No. Let me see. Jupyter Lab. That doesn't answer my question. Alright. Let's see here. Alternate enter. Alternate enter. I think that might be what I'm looking for. Let's see. That is the key shortcut I'm looking for. Alright, so train code what am I doing here? Value counts and yeah. Alright. Alright, so originally this is how many basic, extended, and premium we had in test, and this is 1, 2, 3 we have in the encoded data set. So this way we know for a fact that our encoding works. This is good. I'll go ahead and commit these changes. So git add get comment message. I want to say added, no, let's say encoded coverage from categorical to integer. All right, so all right, let's see. I think we are going to do one more thing, and my list of things to do before we call it a day, and then when we come back next week, we'll continue with this project. And I know it looks as if this project is kind of like slow going, but this is kind of like process you have to go through in data science when you're working on a new project. Like if you just get a data science project and you run to models, you are screwed. All right, so I'm going to do this at the end. I'm going to leave this empty. I'm going to start working with the target at the end, but I'm just going to leave it. Change customer lifetime value to 2 figures, 2 significant figures, okay? Change monthly premium to 2 significant figures, and then, okay, so, what's the, let me see. I want to round a pandas series. I wonder if pandas has a round function. So I could encode education column into categorical. So let's go ahead and do this real quick. So we are going to do this, and this. This one, and this one. Okay, I've done this already. That was the first thing that we did. So a lot of encoding is going on here. All right. So yeah, a whole lot of encoding. So there's a whole lot of encoding that I have to do in this project. But I kind of want to do that. I know like I could just build a function that encodes everything, but I want to do them manually one by one and just make sure everything is done right. So in the case of gender, so for example, in the case of gender, we can't do ordinal encoding. We have to do one hot encoding. You know, because ordinal encoding introduces bias into your model. So in this case, we just do one hot encoding for gender. Employment status. I think I'm going to do ordinal encoding for this too. All right, yeah. So all right, yeah, there's a whole lot of changes we have to make to this data set to make it, to kind of get it ready for a model. So all of this process that I'm going through right now is kind of like pre-processing, what some might call cleaning the data, kind of getting the data ready for the model. And also for visualization too, because as you can see, I have a lot of visualization ideas that I want to create. But before I get to the visualization ideas, I want to clean up my data first. Let's see here. I want to change customer lifetime values to 2 significant figures. I want to encode education into categorical. So let's go ahead and do this while we are still working with category encoders. And then let's look at a way to doing applying round function to a pandas series. So encode education column into categorical. So let's do alright, so let's do this right here. Uh okay. Let's see. And let's do train education column. Dot describe, and something doesn't look right. All right, so we have 5 unique values here. So let's bachelor 1992. So we have 1992 bachelor's, college, high school or below, master, doctorate. So how do we want to categorize this? So I'm going to have to say, let's say we could give high school or below 1. Um, college and bachelor are kind of like the same thing, huh? Could it be that college is people that maybe went to college but didn't finish, and then bachelor is people that have a bachelor's degree, and then masters, and then doctorate? I could combine bachelor's and college into just bachelor, or should I separate them? If somebody went to college, right? Um, yeah, having bachelor and college separate doesn't quite make sense, because college could represent people that did some college but didn't complete, and then bachelor is people that actually have their bachelor's degree, and then masters is people that has a master's degree, and doctorate is people that have doctorate degree. Oh, I could just simplify stuff and combine bachelor's and college. I think I might do that. Yeah, I think I'm going to do that. I'm just going to let's say into one data type, could be that college means people that went to college but didn't graduate. Combined college and bachelor for clarification. And easier assessment. Something like that. So I'm going to combine bachelor and college. So let's do join dot, let's see, education dot replace. I always forget the syntax for replace. Series dot replace so to replace equal and value, okay, and in place I want it to be yes, I want that to be true. So I want to replace this. We have string, regex, list, dictionary, series. Okay. How to find the values that will be replaced? Numeric, string, or regex with whatever is in value. So whatever is in here we replace with this. Alright. String exactly matching to replace. Okay, so if this is list, if to replace and value are both list, they must be the same length. If regex equal to true, then all strings in both lists will be interpreted as regexes. Okay, and then okay, so I could use a dictionary in this format, or I could specify values. I could specify what I want to replace and what I want to replace it with. Cool. For a data frame, a dictionary of values can be used to specify which value to use for each column. So I could use a dictionary like this, which is what I'm going to use, or I could specify what I want to replace and the values I want to use to replace it. If true, in place, no, this will modify any other views in this object. Example, a column from a data frame. The default is false, Alright, so let's go ahead and implement that. Actually, I want I could let me see. I want to use a dictionary. I want to replace college with bachelor. Alright, and now let's do this again. Alright, so now wait, what? Oh, it's an object. Okay, it's like that integer. This is it's an integer. Okay, so now bachelor. So now bachelors and college has been combined into one. So now bachelors and college has been combined into one type. All right. So now we just say bachelor's. Well, we need to do this on the test 2. And at the end, we are going to write a function that does all of this data cleaning that we are doing right now. We are going to write a function that does all of this at once. You know, and yeah. What is this thing saying? Okay, it worked. So why is this throwing an error? I don't know. I don't know why this was throwing an error. Alright, so now that we've replaced this, and we want this to have an order. So we want high school or below to be 1, bachelor's to be 2, master's to be 3, and doctorate to be 4, just because the education column has a natural order to it. Alright, so let's see here. Where is my code? Okay. So if so the column is going to be education, and then if it says that, I want it to be 1. If it says bachelor, I want it to be 2. If it says master, I want it to be 3. And if it says doctorate, I want it to be 4. Alright. And let's see here. I want this code again. I'm going to name this education encoder. Alright. And then I want to, let's see, I want this. Okay, so let's see. We have our education dictionary, education encoder. We need to change this to education, and we need to change this to education. And yeah, we want to perform this on the encoded one. So let's see, let's call this education, and this is also education. I want to fit transform train encoded. All right. All right. Let's do train encoded dot head. So now let's go to the education column. We run into the same problem again. Maybe the problem we are running into is because the name here is the same thing as the name here. Let's just call this 1, or let's just call this 2 to just to show that this is the second work we are doing. Like, this is the second encoding we are doing today. Yeah, the first time I did this, I ran into the same problem with me getting -1 in weird places. So one thing we can do, there's something else I actually want to Google. I want to search how to do round function on an integer on a pandas series. So while I'm doing that, I'm going to clear my kernel and run all sets, because sometimes just clearing your kernel will fix everything. Let's see. So just series dot round, okay. Decimals equal to 0 and then argument, okay. Round values of, actually I think I want to run the values of all the data frame. Let me look at this real quick. Number of decimal places for each one. Index. Alright, so this is done. Let's see. Alright, so this is still not fixed. Yeah, this, I don't know why it's giving me -1 here. That's strange. Yeah, it's giving me -1, 2. Oh my gosh. Now I see what's happening. Oh my. Okay. See, up here when I combined Up here, I combine bachelor's and college into just bachelor's, but I didn't do that for my encoded, and then I provided um, here I didn't pass in the right transformed data frame, so it automatically assigned -1 to 1926. All right, so let's do this. Let's see, what code did we use? All right. So we want to say train encoded, and then also test encoded is equal to this. All right. Let's execute this. Now this should work. I mean, I still left this as train encoded and test encoded. I think that should be fine. If it throws an error, or if it doesn't give us what we want, then we rename it to 2. And we'll give it a different variable name than was here. But let's see. Alright, everything here looks good to me so far. Let's do shift enter. Alright, there we go. Things now work as expected. Yeah, so we have successfully transformed the education column from categorical values to integers. Now let's see. I want to go ahead and comment this. So get add all right, let me see. I should have 2 things in my comments right now. I say your branch is ahead of master by 2 comments. Okay, that's right. Let's do one more thing here before we call it a night. Let's do one more thing here before calling it a night. Let's see here. Decimals equal to 0. Round a data frame to a variable number of decimal places. Okay. Number of decimal places to round each column to. If an integer is given, round each column to the same number of places. Otherwise, dictionary and series round to variable number of places. Column names should be the keys if the decimals is a dictionary like, or in the index if decimals is a series. Any columns not included in decimals will be left as is. Elements of decimals are not columns of the input. Will be ignored. Okay, I think I understand this, but hopefully I do. So columns, okay. 1. Okay, and then with a dictionary, the number of places for specific columns can be specified with the number. Okay. Using a series, so we could use this dictionary format, or we could use this series format to round multiple series at the same time from a data frame, which is exactly what we want to do. So our next objective is rounding various series in our data frame. All right, so we want to round all right, so I want this here because next week when I come back to this project, I don't want to keep scrolling back up. So let's go ahead and mark off what we've done so far. So we want to round lifetime value, monthly premium. Let's see. All right. And then integers, integer change state to integers. So include vehicle class, explore vehicle class. Alright, so these are the only two columns where we are rounding stuff. We are only rounding stuff in the monthly premium and the customer lifetime value columns. Okay. That's what I wanted to know. I think it does the replacement a data frame with the affected columns rounded to the. Okay. So I think this happens in place. I don't need to set it equal. So let's do. We want this to occur on the train encoded, test encoded. Equal to now actually train encoded dot round, and I want to provide a dictionary like. So I want to do, let's see, actually before I do this I want to get the names of my columns. Alright, so total claim amount. Total claim amount, was it like, let's look at total claim amounts real quick. Okay, so number of complaints. want to check this real quick. Okay, so we also need to clean up total claim amount to two significant figures. All right, and the reason because dollar, is only up to two figures, so total claim amount is another one that needs to be cleaned up. Income also, let's say income needs to be okay. Income is already in the two significant figures range. That's good. All right. All right. So let's go down here and say lifetime monthly premium and total claim amount. And income just to be on the safe side. No, income is already rounded to two figures. So now here we have to provide a dictionary. So let's say we have to do decimals equal to, so in this case, the way they did it here. So we don't have to do decimals equal to, we just provide a dictionary. I see. So we want customer lifetime value. We want to round it to two significant figures. And then we want monthly premium auto. Are you sure that's not already in two figures? Because they should be, so, but let's see. Yeah, monthly premium auto is already in two significant figures. Or either one or two significant figures. So that's not necessary actually, so what we do need here is the total claim amount. And I also want this to be two significant figures, so yeah, this makes sense to me. I said thanks. Sense to me. Let's go ahead and execute this. Alright, so let's see. This is probably for train, so let's do train encoded dot head. Yeah, let's do dot head. Huh. It seems like this didn't work. But it worked here. Oh, I see. So the replacement didn't happen in place. I could do in place equal to true, but I'll rather set it up differently. So if you look here, this is two significant figures, but if you look here, it didn't work exactly the way we wanted it to. So let's fix that real quick. And now let's do this. See, now it works. All right. So I also want all right. I think I also want this applied to my original train and test data set. I have my train encoded, which is my test encoded, which is like the data set where I'm making all the changes to. But I also like to keep my original train and test data set just so I could easily call upon it when I need to. So I'm going to do, I'm going to do this here. All right. So that's pretty much it so for today. So today we did a whole lot of stuff, and correcting that real quick. So yeah, so next week when I come back to this project, I'll do a few more. I'll do like the remainder of the data wrangling process that I need to do to clean up this data set and take my categorical values from being categorical values to being integers. And then after I've done all of that, I'll do code refactoring, where I take all of this data cleaning process and put it in a function. So I'll take everything I did today and put it in a function. I'll take everything that I'm going to do next week or even next 2 weeks and put it in a function. And that will be our data wrangling process. Alright, so that's kind of like the basic data wrangling process that I'm going to be using. And then we'll start exploring the data set by creating different visualizations to get an idea of what our data set looks like. So that's going to be fun. But in the meantime, I am pretty much done for today. If you are here, you can ask questions. But if not, I'm going to end this live stream. It's almost 9 p.m. Pacific time. So I'm going to go work out, take shower, and go to bed. I have to be up by 7 a.m. tomorrow morning. So yeah. But this was fun. I'll be back next week, Monday, to keep working on this project. Yeah, I really enjoyed it. Before I close everything out, let's go ahead and get add and get commit. The message is going to be what did I do? I rounded some series in the data frame. Get status. Right now it should be 3 commits ahead of branch. Yeah, it is 3 commits ahead of branch. Now let's do get push origin master. Let's do the get status, and we are up to date with origin master. And let's just go online and verify real quick. Alright, rounded some series in data frame. Yep, 32 seconds ago. And 6.5 meg. I think last week it was 3.4 megabyte. Now it's 6.5. So almost double. So I'm just making sure all my changes are here. this is like, this looks like my latest change. Yep. I always do this step and make sure and verify everything is on GitHub before I close things out, because there has been times when I close things out only to realize I didn't push it to GitHub, or I pushed it, it didn't go through, or stuff like that. So I don't want any of that shenanigan. And of course, you can always come to this GitHub repo to look at this project. And also you can visit me online at evidencen.com. Here I have a whole lot of tutorials in data science, so you can come here and visit, and make sure to subscribe to the YouTube channel. And next week when I come back, I'll continue working on this project. And then if you go to free data science resources, you come to a page, machinelearningeducation.com, where you get my free data science resources. And if you just go to the homepage of machinelearningeducation.com and just go to I believe free data science resources view bundle, or just go to machinelearningeducation.com/free, machinelearningeducation.com/free. You can get access to my free data science resources, and under this I have data science books, data science cheat sheets, data science job and career resources, and data science tutorials. So data science tutorials, where I put all my code, videos, podcast, tutorial content goes here. And then these are the job and career resources, are like kind of resources are found online. Books are like free data science books are found online, and cheat sheets are found online. So basically I scavenger hunt the internet, find useful resources, I put them together here. But this is kind of like where I put my original content. So if you've seen any of my YouTube videos or any of my blogs and you want access to the notebooks that are used in my tutorials, this is where you find it, under data science tutorials. So yeah, this is my free resources. Take advantage of it. And of course the link to this is in the description below. That's it for this video. Thank you for watching, and I will talk to you again next week, Monday. Bye.